Here we've got 7 steps that we're going to use to graph a parabola. Get your equation into standard form. The variable that is squared should, or the variable without the square term should be by itself. And we can always pull the fraction in front. Determine whether the parabola opens up or down, left or right. Find the vertex, draw the axis of symmetry, determine the p-value, determine the directrix, and draw the parabola. I might do these out of order, but those are all the steps that you need to include as you graph the parabola. Sometimes if I see that one of those aren't needed, I just skip it, but you need to make sure you cover all those steps. So first, finding the vertex, focus, and directrix of the parabola given y equals 1/2 x squared. Now you know 1/2 x squared is just going to be a parabola that opens upward that is slightly wider. Well, let's go through all the steps. First of all, the vertex here. We can see that there is no shift at all. There's no x minus 4 quantity squared. There's no h's or k's in there. So I know my vertex is going to be at 0, 0. The next thing that I need to find are the focus and the directrix. But in order for me to find the focus and the directrix, I need the p-value for both of these. The p-value ties directly to the focus and the directrix. So I've got to make a little comparison. I know my original equation is y equals 1/2 x squared. And my standard form for the parabola is 1/4p x squared. So if I look right here, 1/2 to 1/4p, the relationship, I know that 1/4p has to equal 1/2 because those are the same pieces of the equation. And since this form here has to equal the standard form, 1/2 is equal to 4p. So then I can solve out this little equation here, 1/4p equals 1/2 to solve for p. So we can cross multiply. So 4p is equal to 2. Divide both sides by 4, which means p is going to be 1/2. This is not always the number that is the p-value, so don't fall for that. You've got to actually work it out to solve it. So here we can see that p is 1/2. The p-value tells us the distance that the focus is from the vertex and the distance that the directrix is from the vertex. So if I graph this out, I know I've got the vertex at 0, 0. This is a y equation. The y is not squared, so it's going to tell us it's going to open in the direction of the y-axis, so it's going to open up or down. The fact that my p-value here is positive means it's going to open in the positive y direction. So my graph is going to be something that looks like that. Now where are the focus and the directrix? The focus has to be inside the parabola. The directrix is outside of the parabola. So if I know my p-value is 1/2, that means my focus has to be half a unit up. So that's going to be 0, 1/2. So my focus is going to be 0, 1/2. The directrix is the same distance as the focus is, but in the opposite direction. So my directrix is down here, and the directrix is going to be the line y equals negative 1/2. So the distance here and the distance here have to be the same. So there's all the pieces of our parabola. Focus is inside the parabola, directrix is outside. Directrix never intersects the parabola. We found our p-value, which helps determine the direction our parabola goes and where our focus is going to be located. Example number 2, finding the standard form of the equation of a parabola with the vertex at 0, 0 and the focus at 0, 2. Well, we know something if I start drawing this parabola out. I want the standard form, and I know the vertex is at 0, 0, and the focus is at 0, negative 2. That tells me that since the focus is down, my parabola has to open down, because the focus has to be inside the parabola, which then means if I wanted to find it, the directrix would be up here. And in this case, the directrix would be y equals 2. Since we've got 2 units down to the focus, we need 2 units up to the directrix. So my p-value is 2 units. Since I've got this parabola here, we'll use our standard form for a vertical parabola, which is going to be y equals 1 over 4p x minus h quantity squared plus k. But since both of these are 0, the h and k are 0 since we're at the vertex, we're just dealing with 1 over 4p x squared. My p-value is 2 units, and since I'm going down, I'm going in the negative direction 2 units. So I'm going to get a negative 1/8 x squared as being my standard form for the parabola. Now, one of the things we also want to look at with these first 2 examples would be, how could I write these in parametric form? And it's actually really easy to write these in parametric form. Remember, one of the tricks we learned when we graphed the parametric form is if we set x equals t, then the y equation is just the original equation with a t substituted in. So if I wanted to write example number 1 in parametric form, I could say let x equal t, and then y would be 1/2 t squared. Down here, if I were to write this in parametric form, the easiest thing is to let x equal t, and then y would be negative 1/8 t squared. Just make a little note that you can quickly convert your parabolas from rectangular to parametric by doing that little trick with the t values. And the reason we do that is when we start getting to the more complex parabolas, it's going to be a lot easier to type this in than when we get these parabolas that have plus or minus square roots of a lot of stuff. So we just want to know how we can quickly convert to parametric form in order to help us graph.